Warm greetings and wishes. Today we are going to see about the truss analysis in two dimension. The case of truss analysis, we can use two or three methods. In the case of 2D, the first method, which is called as method of joints, and the second method, which is called as method of sections. So when will you go for method of joint? The case of method of joints, if you want all the member forces, either inclined member or a vertical member or a horizontal member, top chord and bottom chord members, so you can go for the method of joints. If you want only two or three members forces in the case of truss analysis in 2D, you can use the method of sections. For example, it consists of 15 members in the case of truss, any member, any truss. I want only 3 or 4 members out of 15. Even you can go for method of joins, but it will take time. It's a cumbersome method if you want only 3 or 4 members. So instead of that, you can go for method of section. It is a very easy method, and it is not time consuming. You can find the 3 member or 4 member forces directly in the case of method of section. So before going into the method of sections, so how will you find if a given truss is a stable truss or unstable stress or a deficient method, etc. So the truss can be analyzed or coming into the category, that is when m is equal to 2j minus 3. If the number of members is equal to the right hand side equation 2j minus 3, or m is greater than or equal to 2j minus 3, it is called as a perfect stress or a perfect frame, and j is the number of joints. For example, if you are taking a equilateral triangle truss which consists of 1, 2 and 3 members, and the number of joints is 1, 2 and 3. So 3 is equal to 2 into 3 minus 3, so that is 3. So left hand side is equal to right hand side, that is 3 equal to 3. So it is a perfect stress. And in the case of imperfect truss or imperfect frame, so if you take it, the number of members is less than 2j minus 3, so it is called as a deficient truss or a deficient frame. For example, in the case of a truss, so which is a box type of girder trusses, there are 2 box trusses is supported in the wall or the column. If the number of members is 10 and joint is for example 5, so it is m is equal to 10 is equal to 2 into 5, 10 minus 3, that is 7. So again here it is a perfect stress. So when m is not equal to 2j minus 3, it is called as imperfect stress. Whether imperfect stress is a redundant truss or a deficient truss or a deficient frame. So if the number of member is less than 2j minus 3, for example it is m is equal to 4, 2j minus 3 is equal to, say for example 6. So here 5 is not equal to 6, so it is called as a deficient frame. So the number of member required is extra required is 1, so to become the deficient to the perfect stress. So therefore if m, for example m is 12 and 2j minus 3, right hand side equation if you are getting as, so you are getting it is equal to or not equal to, right? So it is 15 again. So the number required is another 3 so that it can make a perfect test. That is called as a deficient frame or a truss. But in the case of redundant, so if the number of member is more than 2j minus 3, for example, 12 is not equal to, right hand side equation is what? So you are getting, for example, 7. So in that case, you have to reduce another 4 to 5 members so that it can make a redundant to the perfect test, or you can add in the case of redundant or the deficient frame. Either you are adding or deleting some members so that you can satisfy m is equal to j minus 3, right, from deficient frame to the perfect test or a perfect frame. So this is about the type of trusses based on the equations of equilibrium equations of truss analysis in 2D. So you know that the truss, the very simple form of truss is a triangle, either right angle triangle. It consists of 3 members and 3 joints, or equilateral triangle, 60 degrees, 60 degrees at all points. So from that, you can go for the next video about the method of joint. Thank you very much. God bless you. Valgaviyam, Valgodam.